Welcome to the series of my AI videos. Today's video is Advanced CSV and DB Agents. We already looked at CSV Agent. If you remember the video of topper of my class, right? That was a simple CSV agent. We also did some DB agents like some troubleshooting chatbots, some support queries, right? Now, let's just recap this simple agents, right, that we looked at. So basically, we have a user, right, which makes a query, right? Then here, you can use different frameworks. I have chosen LangChain here, right? Obviously, most of these are Python-based frameworks, okay? Uh, and then locally, they either have a database, right, for which they'll use a DB agent, or they have a bunch of files or a CSV comma separated value files, right? And then they'll use a CSV agent for that. Okay, now typically they will use API to access some cloud uh, provider for the LLM, right? And which give some interesting results. Okay, so this is a simple agent. Okay, now some techniques we'll see like a prompt injection. I mean, rather than just taking the user query, you add some context to that. Okay, and we'll see that in a bit. Okay, so that was our simple agent. Okay, now uh, here are some sample codes, right? So let me jump to this CSV agent, right, which is what our topper of class was, right? Now, if you go here, basically what you see is I have some tables, right? Now let's say I'll go to this my class, right, which was my CSV agent, right? So you use a chat OpenAI. I'm using a local Olama, as you know, right? Now, basically the only thing that you have to use is a create CSV agent, right? Basically, which is this for the LangChain experimental agents toolkits. Okay, this create CSV agent. Now, you provide the tables some prompt uh, injection techniques you can use. You can say a prefix, right? Now whatever you add here is basically kind of your system prompt. Okay, now it also supports suffix, okay, which is basically a few short prompting, right? So this is how you can do prompt injection. Okay, uh, and then you basically give some additional parameters, keyword args. Okay, and that's it. And then you say you invoke the agent with your input, okay, and you get the output. Okay, so that is one way. Okay, now there are some other ways you can do it is through the tools. Okay, so I'm using this Python tool, Python AST REPL tool. Okay, and you use a initialize agent from here. Okay, and that's how you run this agent. Okay, so basically it's either a create CSV agent or it's a initialize agent from the LangChain agents. Okay, and a simple CSV agent. Okay, similarly I have a simple DB agent. Right now this DB agent basically has as it says create SQL agent, or it's a create React agent. Okay, now we'll see this SQL agent. Okay, so all that you do is you basically uh, okay, this is for the React agent. Okay, this is for the second example. So with the React agent, you have to give you have to get the tools from the SQL database toolkit. Okay, which is what you'll see here. Okay, and other one is this basically connect to your database and you execute create SQL agent. Okay, as simple as that. Okay, now some tuning that you can do with these simple agents is using some cloud providers, right, like OpenAI, Anthropic, popular ones, so on and so forth, and can choose the model, right? So typically for SQL or this pandas data frame, you can use any coder model, right, like a Qwen coder, right, uh, deep seek coder, right? I mean some coders model will be good. And of course, some tuning is this prompt engineering that we saw, right? Adding a system prompt, giving additional context, doing the few shot prompting, right? So basically, that's pretty much only tuning you can do with simple agents. Okay, now what are the limitations with the simple agent? So imagine like you have hundreds of tables, maybe thousands of columns, right? Now, basically that's a context overload, right? Now, if you want to answer a query which requires only maybe two, three tables, maybe a few columns, right? You don't have to give all this huge schema that you may have, okay? So it's like thousands of tokens, right? It's not only the cost, but LLM may get confused. It may not give good results, okay? Because of this context overload. Second thing is a hallucination about table and column names, right? So LLM may hallucinate, right? And not only just with schema, but it can hallucinate with data also, right? I mean, it basically uh, doesn't realize it's given the data, right? And it will like, maybe hallucinate with some data. It will create some sample data, okay? uh, Ambiguous natural language, right? I mean, you may say salary, right? But maybe in your table you call that column as compensation, right? Topper, right? When you say topper, what do you have to do, right? Do you have to uh, sum up all the marks for a student for all the subjects and get the max, right? I mean, it can be tricky, okay? Joint discovery, right? LLMs are not very good at discovering joins that are required, right? And then there is a schema drift, right? What if you rename the tables or columns, right? The LLM may not do good, okay? So what are the solutions, right? So here is a multi-stage enhanced architecture that we can put in, right? You get a natural language query, then you normalize the query, right? So clean the input, right? You expand the synonyms, right? You detect some ambiguity, okay? Now one key thing that we'll do here is we'll do some sort of a RAG, retrieval augmented generation for the schema, right? Then we'll ask LLM to give uh, a specific structure for the query, right? We'll call it a query planner, right? So we'll say what is the intent, what are the metrics, so on and so forth, okay? And then we'll either give it to like a SQL builder or a data frame or a pandas data frame builder, okay? So here we'll use SQL alchemy, right? Or will use the data frame, okay? And then you execute, right? So basically this like a 4-step architecture, right? And then obviously once you get the results, you can even sort of check, put some limits, do some type checks, okay? So let's do a deep dive, okay? So the first is the schema indexing, right? So that you do only once, right? Which is the whole beauty of this, right? All these like hundreds of thousands of tokens that you may have with hundreds of tables, thousands of columns, right? That you kind of uh, take incur the cost only once, okay? Now while retrieving uh, the schema, right? That will do on every query execution, right? But we'll retrieve only very small subset of the schema, okay, for execution. Now for this, you need a schema registry. So you can use various different tools that are there for RAG, like a Chroma, which is very popular, or a Face, okay. Now the second step is you ask LLM. So this also one of the videos we have done, right? A structured LLM output. So you can tell LLM not to give the free form output, but some structure, right? You can specify a JSON. For example, you can have a query planner, right? And we'll see that in a bit, okay? So LLM will generate output only in that form, right? So basically this is your query planning, okay? Now once LLM gives this query, generates this query in that particular format, right? You execute it, right? So for this execution, you can either have a SQL or for pandas data frame, you can have some Python tool, right? Now, these steps 1 and 3, you can do direct tool calls to avoid some latency of LLM calls, right, as well as cost. Okay. Okay. So now look at some code. Okay. So we'll look at CSV agent. Okay. Now the simple CSV agent now pretty much can get very complex, right? So first we'll do this schema building, right? Now this happens only once. You kind of get your schema, right? You break it down and you store it in FAS in this case. Okay. Now, how does this schema look like, right? You may ask. So that will be in the schema registry, right? So I'll say marks, subjects, right? Students. These are my tables. Now, uh, what does this table store, right? What are the different columns? For each column I can give description, right? Now here you can see I can give a lot of synonyms, right? And then this similarity search can kind of get this interesting result out of this particular rag. Okay, so we'll look at that like a schema retriever, right? So in schema retriever, you basically use the embeddings, okay, which will give the similarity search, right? And you do a similarity search. Okay, so whatever question you got, uh, you kind of get the similar schema, right, for the question that was asked. Okay, so this is the schema indexing and the retrieval part. Okay, now let's look at another interesting part, which is basically uh, the planner schema, right? So in the planner schema, I'll say now this is like a standard data frame, right? So in data frame, you have a join, you have a order by, okay, and your query has tables, joins, group by, aggregations, order by, limit, okay, and that's it. Now in the planner, right, to the LLM, you say that like you must return only valid JSON matching this schema, right? So whatever schema we had for our query, we specify that. Now the moment you tell uh, LLM to give output like this, it will be structured output, right? Which is what you can just uh, give to your executor. Okay. Now another interesting context you can give, like, and you can experiment with your data and queries, and you may want to add these clauses. Like for example, I have added that for top, highest, lowest, right? You use the group by, aggregation by sum, ordered by, and then limit. Okay, now group by must be over a column representing unique values for a chosen table. For example, for students, I have a student ID and a name, right? But the name can have duplicates, right? So I don't want to uh, basically set off my result because of those duplicates. So I would like to do my group by the student ID, right? Which is what this is saying. Okay, and that's it. Then you can do some validation, right? Now, if you look at my run query, basically it's a pipeline, right? So where I load the data frames myself, right? I don't ask LLM to do that, okay? Uh, and then I run the pipeline. First is retrieving the schema, then I plan the query, right? This is a query planner that we saw, right? Which will give like a JSON, a valid data frame query, okay? And then you execute, right? Now in execute, right, I can put all this logic, uh, how I want to execute this query, okay, and that's it. That is my custom CSV agent. Okay, now uh, one optimization I can do, right? This is as you could see, it was a lot of code, right? Could be a lot of complexity, could take a lot of time to execute, right? So the other approach I can take is basically doing the complete tool based, right? So here, obviously the schema stays the same, indexing retrieval is kind of same, right? But the main change you'll see in my CSV agent would be in the pipeline, right? Uh, you will see very simple pipeline, right? Where again I did this sort of schema retrieval, right? pipeline that I retrieved the schema, right? Uh, then I got the Python code by uh, invoking the LLM. Now this is the LLM call, right? Once I get the code, I just uh, execute it, right, with the Python tool. So as you could see, this was the only LLM call, right? The schema I invoked like a tool, like a function call, right? And I directly invoke this tool, okay? So that is one way you could do this CSV agent, right? So similarly for a DB agent, I'll just show the code. So DB agent I have done only tool based, right? Where again it's kind of similar for schema indexing and retrieval, right? With the Olama embeddings in my case, uh, and you just have a execute SQL, right? So in the pipeline, right, you retrieve the schema, right? Now this is the only LLM call, right? Now here, it's very interesting that LLMs are very good at giving SQL queries, right? I don't have to give very complex sort of JSON and all that, right? I can just say that give a SQL query, and this is a very good job. Okay, now again, depends on the model, right? Again, I have used the coder models, so they do pretty good, right? So you invoke the LLM, you get the SQL query, and you just execute. Okay, so the execute is basically you just use you may basically make a connection to the SQL server, right? And the you use the SQL engine, right? So I'm using a SQL Alchemy, right? Create engine, right? Which is what you use, right? Uh, and you use that engine uh, to execute the query, right? You connect using the engine, right? You execute the query and you get the results. Okay, so now as you can see, right, you can put a lot of custom logic here, right? Right from the first stage of schema retrieval, right? With the RAG query planner, right? Then you build a query and you execute. Okay, so if you like the video, click the like button, subscribe to my channel, and good luck exploring these CSV and DB agents. Bye, see you in the next video.